everybody! Welcome to episode number 566 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. My guest this week is Deepali Trehan, VP Intel Programmable Solutions Group Product Marketing, and we're diving deep into the world of chiplets and FPGAs. Deepali and I discuss why there is a big interest in chiplets lately, the biggest benefits that chiplets provide when it comes to the design and manufacture of programmable logic devices, and where Deepali sees chiplet technology headed in the future. So, without further ado, please welcome Deepali to Fish Fry. Hi, Deepali. Thank you so much for joining me.
Great. Thank you so much for having me, Amelia. Excited to be here.
Excellent. Okay, so we're talking about chiplets, FPGAs, and the future of programmable logic today. But Deepali, first, why do you think we have seen such a huge interest in chiplets recently?
Excellent question, Amelia. First and foremost, I'll make a statement. FPGAs and chiplets is such a killer combination for driving rapid innovation in the industry. And I'll talk a little bit more about why do I believe that. So chiplets actually represent a huge opportunity to satisfy market demand for more processing power, unique digital capabilities, and more flexibility to innovate and achieve faster time to market for our customers. You look at application segments such as 5G now going to 6G, optical systems, infrastructure acceleration, industry controls, smart automotive, medical diagnostics, defense, video systems, and just many more that are begging for new, more powerful, and highly innovative solutions. And a desire to rapidly infuse, like, for example, AI into data center, AI into the network, AI into the embedded devices at the edge is another key driver that we see for broad chiplet adoption. Systems that are built with chiplets can be the fastest way to deliver the needed capabilities, the most cutting edge, innovative capabilities out there in the industry. It's been clear for a while that we need to have some new options to meet the demands of digital transformation and to continue the pace of increased performance, smaller footprint, and reduced power consumption going forward. I mean, think of multi-chiplet system as a new degree of freedom that gives us the ability to combine more silicon functionality, more transistors, more logic, more processing, all that packed into a system per se that can deliver more performance and less power consumption with smaller space. And great example where it becomes more and more so difficult to get good die yield, for example, as you increase the die area, we know that it's harder to get great die yield. So it can be more economical to combine these multi high yielding chiplets than to insist on a single monolithic device. And so combining these multiple chiplets tightly coupled in close proximity can overcome the limitations permitting larger systems that deliver this excellent performance. So, it can be beneficial actually to combine some of the silicon manufactured with different process nodes, for example, into an integrated system. Not all functions scale with process, especially external interfaces such as those that involve like analog circuits, like transceivers and data converters. So, external interfaces often have fixed electrical specification that may not necessarily match the latest process or require trade-offs in performance. And so there are both economic as well as performance advantages to combining chiplets that are manufactured with different process nodes or from different manufacturers into these tightly integrated devices. So really, why I say there's a huge interest in the chiplets recently is their ability to really deliver cutting edge technology innovation at the fastest possible way, because that's the way to go. Chiplets are now opening new horizons for complex high performance solutions. We would like to explore For example, how a combination of a chiplet technology with the flexibility and lower power consumption of FPGAs, now you start combining these two and really accelerate that innovation in a wide range of applications, from data center to embedded systems to network to virtually all industry segments that you can think of. So excited about the opportunity that presents. And for us, we have actually made a statement last year in 2023. As of today, we have shipped over 10 million FPGA based chiplets out there in the industry to many, many customers, many, many application segments, and so on. So, really excited about that.
Excellent. Now, speaking of Intel, you guys have been incorporating chiplet technology into your FPGAs for years, right? Tell me a bit about the history here.
That's a great question, Amelia. So, chiplet technology certainly isn't new to Intel per se. We put a CPU chiplet and a fast static memory chiplet acting as a large L2 cache together in a single package to create the Pentium probe that was introduced back in 1995. And Intel actually offered a product that combined even an Atom processor chiplet with Altera FPGA almost a decade ago. So the challenge has always been how to interconnect chiplets mechanically, electrically, and thermally into a package that meets the intended overall system requirements. And this requires not only new signaling, power distribution, heat management, and manufacturing techniques, but also interface standards that allow chiplets from multiple sources to work together reliably. We have been working as Intel have been working on all of these challenges for over 2 decades. And let me give you some examples. Some of the results that include are the 2.5D EMIB, which is our embedded multi-chiplet interconnect bridge for side-by-side chiplet integration, and the 3D Foveros packaging technology, which enables vertical chiplet stacking. We also developed a standard chiplet to chiplets data transfer protocol called Advanced Interface Bus, or AIB. And today we are working with partners in the ecosystem to take this to the next level with UCIe, which is Universal Chiplet Interconnect Express, which is a serial bus specification and protocol stack for communication between chiplets. So UCIe is an open standard which is co-developed by multiple renowned companies out there with the likes of AMD, ARM, Google, Intel, of course, Meta, Microsoft, Qualcomm, Samsung, and TSMC, maybe a few others as well. And we have demonstrated multi-chip packaging success through our work with BAE systems to deliver multi-chip devices to US Department of Defense under DARPA CHIPS program. So this technology will really give our defense system an 8 to 10x improvement in size, weight, and power in very, very challenging environments. And I believe our Intel Ponte Vecchio GPU sets a record with 47 active chiplets in a single package. And these chiplets are manufactured by multiple semiconductor vendors using 5 different semiconductor process nodes, and all combined in one package to introduce an integrated product with more than 100 billion transistors. I pause there and repeat, 100 billion transistors, something not currently possible in any silicon die, I would say. I mean, Stratix 10 FPGAs, which was our first production and iteration of the EMIB chiplet interconnect solution. And Stratix 10 has been an Intel FPGA that's a center of it, and up to 6 chiplets surrounding the FPGA, 4 high-speed transceiver chiplets and 2 high-bandwidth memory chiplets, all assembled in a single package. And this product integrates 6 different technology nodes from 3 different foundries. So it's a great proof of interoperability that you see across suppliers. And the reuse of chiplets in our FPGA products have been the foundation for a long line of product firsts that we have delivered to the market with our Intel FPGAs and SoCs. I mean, you look at in February 2018, we introduced the industry's first 58 gigabits per second PAM4 SerDes transceivers implemented as separate chiplets within the FPGA package. In 2019, we introduced and announced the first FPGA listed by PCIe Gen 4, the first FPGA with more than 10 million logic elements. Our FPGA leadership continued in the following years with the first 2 terabits per second chip to chip optical interconnect, the first certified PCI Gen 5 by 16 interconnect operating at 32 GT per second, and the fastest in package analog to digital and digital to analog converters, A to D and D to A converters, enabling direct RF conversion all the way up to 64 gigabits per second. And last year in 2023, we ramped up our PAM4 SerDes transceiver speed all the way up to 116 gigabits per second and delivered our first FPGA with Gen 5 and CXL hardware support. So why am I saying all this? If you look at our history, Intel and PSG have been a pioneer in the area of chiplet technology. All these advances were all enabled by chiplets that were incorporated into our FPGA products. And we have a lot more in our portfolio that we are currently working on. And our roadmap plans incorporate also a lot of exciting products and innovations that we intend to deliver to the market.
Fantastic. Now, Deepali, what do you think are the biggest benefits that chiplets provide when it comes to the design and manufacture of programmable logic devices?
Yeah, Amelia, there are two actually huge benefits in using chiplets with our FPGA designs. Firstly, we can deliver capabilities that simply aren't available using other techniques because we can employ the optimal manufacturing process for the intended purpose. I've touched on some of those capabilities just now in our long line of industry first. We are extending this approach now to include our chiplets manufactured by other industry partners such as TSMC and global foundries and standard interfaces such as UCIe to give customers the widest possible choice of capabilities to create most optimal solutions for their end customers. And in addition, so the second benefit is chiplet architectures provide the greatest amount of flexibility in combining specific capabilities needed to meet a target design envelope. This goes quite nicely with the inherent advantages of FPGAs in terms of customization, optimization, and adaptability over time. You can quickly now incorporate existing IP into a solution rather than designing from the grounds up. And that reduces cost, that reduces risks, that reduces time to market by eliminating some design tasks. And since you're using, let's say, for example, some hard IP, you can also reduce a lot of work required for testing and certifying, evaluating, doing validation of the functionality. A case in point is the utility of incorporating chiplets to provide you next generation standardized high speed interfaces such as PCIe, CXL, and connections to high bandwidth, low latency memory such as DDR4, DDR5, LPDDR5, and HBM2E. So, this building block approach really allows the engineers to focus on the unique aspects of a solution by taking advantage of the programmability of FPGA devices. The fabric of an FPGA not only enables custom logic functions, but acts as a basis for a customizable data transfer architecture to optimize interactions among the selected IP building blocks, which can include standard embedded processors as either soft or hard IP. Now, for functions that are not available in IP, FPGAs can be programmed at the hardware level to deliver greater acceleration for performance critical workloads and functions than standard off the shelf components or other software only implementations. So FPGAs with chiplets are an ideal environment, in my opinion, for getting leading edge functionality, cutting edge innovation applied to a very specific application in the shortest amount of time. So time to market is a key great advantage of leveraging that modularity that comes with chiplets. It really allows you to get that time to market advantage. As an added plus, if the solution space involves evolving technologies or standards, FPGA based solutions can adapt to follow the changes, reducing again the R&D costs as well as delays. Often, you see updates can be implemented in the field to improve our customer support and extend really that product lifetime. So lots of great benefits that come with chiplet that really is going to enable the next generation innovation for industry as well as drive rapid transformation.
So, Dipali, where do you see chiplet technology and FPGAs working together in the future?
Yeah, as I think about future, together FPGAs and chiplets offer a huge opportunity for rapid innovation. Chiplets enable fabulous startups to create specialized capabilities that can be incorporated into a wide range of applications. And while FPGAs provide a framework to integrate new IP into leading edge solutions. And so, one of the main value propositions for FPGAs is reducing time to market compared to full custom ASICs. It just gives you such a vast amount of flexibility, and that's the key inherent value prop of FPGAs. And with chiplets, we can provide FPGAs with advanced features and capabilities such as latest and greatest processor interfaces, highest data rate transceivers, or fastest data converters so our developers can quickly add these capabilities into their end products to meet new needs and differentiate their products from their competitors. We'll see more of this synergy between chiplets and FPGA going forward, and we expect the ecosystem of hard and soft IP providers to grow exponentially. We will see chiplets and FPGAs working together to accelerate broad range of applications specific processing, like, for example, the one that is needed in AI, in imaging, in speech, and in video, and just many other applications. We also see new interfaces to advanced sensors, optical networking, and wide range of IoT devices. General purpose processors, including ARM, x86, and open architectures like even RISC-V, are already available in soft as well as in hard IP as FPGA options for overall control functions. We are seeing rapid expansion of capabilities to support AI, both special hardware like tensor processing engines and AI developer environments like OpenVINO to quickly implement this customized AI inference engines for pre-trained and optimized AI models. FPGAs provide a unique platform, Amelia, for integrating AI directly into embedded platforms that also need sensors, actuators, and high bandwidth signal processing to interact to the real world. And we'll also see more comprehensive tools to make it easier to program the FPGA fabric and to integrate the overall solution, working across chiplets and FPGAs to optimize the overall system and package for cost, performance, for your footprint, or for power consumption. And tools will continue to improve and enhance the ability to quickly migrate designs from FPGAs to structured or custom ASICs with less time and effort. It's all about ease of use. There will be more commonality among these implementation modes so developers can plan a migration path based on their specific competitive and economic factors. Solution providers who learn how to take advantage of this potential will have substantial advantage over competitors who view the implementation decision as a fixed either or trade off. Ultimately, chiplets combined with FPGAs can expand the upper limits of what we call it a system and package functionality and complexity. Synopsys, who's also one of our partner and customer, refers to this as SysMore era, where multi-chiplet interconnectivity allows systems to continue to increase in complexity at the traditional rate of Moore's law. Intel also sees this as a next major evolution of innovation in Moore's law. While FPGAs are not a requirement for developing multi-chiplet systems, they do offer unparalleled, I would say, platform for prototyping and fast time to market, followed by quick migration to both up level as well as down level your product family expansion. I also believe that there is a need to get a wide range of engineers and software developers, and not just FPGA engineers, familiar with FPGA based platforms, developments, and our development environments. And these currently comprise a variety of logic description and programming languages, digital signal processing, and AI development tools, extensive libraries for a wide variety of functions and system simulation, as well as our optimization tools. So the future isn't just chiplets and FPGAs working together. There's a huge need and opportunity to leverage software in this mix in several ways. For example, you can make an FPGA into a very targeted programmable processor with an instruction set completely optimized for a particular application. It may only have a few very powerful instructions, such as, say, for AI or for signal processing, but these few instructions might accelerate an overall application by a couple of orders of magnitude. And now, the combination of specialized instructions with standard embedded processor chiplet and some very high bandwidth memory and IO chiplets all comprise a platform that can be utilized by software developers to build an unmatched solution for our targeted applications. On another note, on the future, I would say for FPGAs and chiplets, you may have heard that our division, Intel's Programmable Solution Division, will be operating as a standalone Intel company like Mobileye and some of the others. And we would like to also let you know, if you're interested in knowing more about what does this mean for the future of FPGAs and how we plan to unleash greater innovation for our customers, please do join us for our webcast that's coming up on February 29th. And so, really excited about that. And we're going to talk a lot about our future strategy, our journey, and how we're going to unlock a lot of this innovation through chiplets and some of the other roadmap products that we are planning in future. So, a lot is happening, and I'm really excited, Amelia, about our future together in the industry.
I love it. All right, Deepali, it is time for your off the cuff question. So, since you haven't been on my show before, you get the standard off the cuff. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there. What would you have?
Oh my. Well, I of course love all kinds of cuisines. I'm a vegetarian. Let me first caveat that. I'm a vegetarian, but I love all kinds of cuisines. Some of my favorites. It's hard to pinpoint one. I love Italian. I love Thai. I love, of course, Indian. I born and brought up in India, so I love Indian as well. But there is a restaurant actually in the city. It's Greens. That's a vegetarian restaurant. I love their cornbread. I love also a lot of their salads. They do a lot of fusion kind of innovation in their food area. So I just love that. And yeah, every time I'm in the city, in the San Francisco city, I stop by at Greens restaurant. Just love their food.
I love it. Well, Deepali, this was super cool. Thank you so much for joining me.
Thank you, Amelia, for the opportunity. Really appreciate it. And I hope this was very valuable. We are very excited about our journey ahead.
Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into X, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. And now we are also on Blue Sky Social and Mastodon too. And we also have a YouTube channel, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And of course, you can subscribe to our EE Journal YouTube channel as well. And if you haven't already, make sure you subscribe to this here podcast on Spotify, Google Podcasts, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to some really exciting upcoming episodes. Thank you, everyone, for tuning in. If you know of any cool new technology or hack you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of January 19th, 2024, I'm Amelia Dalton, and you've been fried.